Hello, my name is Dylan Buckner. It's April 13th, 2025, and this is my presentation on the science of software vulnerabilities, understanding, exploiting, mitigating code level threats. And let's dive right on in. So, today we'll be diving into the world of software vulnerabilities, what they are, and why they are important, and how they happen. How can we fight back? So, we'll explore the science, real world examples, and strategies for mitigation. A software vulnerability is a flaw or weakness in a system that can be exploited to compromise its integrity, availability, or confidentiality. Think of them as open doors, not always visible, but dangerous if discovered. Buffer overflows. This classic vulnerability happens when a program tries to write more data into a memory buffer than it's allotted for. The overflow can overwrite adjacent memory, leading to unpredictable behavior or even an attacker control. For example, in C or C++, if proper bounds checking isn't in place, a malicious input could inject executable code. Exploiting buffer overflows can involve overriding return addresses on the stack to redirect code execution to malicious payload shellcodes. Attackers may use techniques like NOP sleds, address space layout randomization, or ASLR bypass, or return oriented programming, or ROP, to reliably gain control. SQL injection, or SQLI. Here's where science meets structure. SQL injections happen when input isn't properly sanitized. Instead of sending safe input to a database, an attacker sends actual SQL commands. A log field like admin or 1 equals 1 could grant full access. A command injection. Unlike SQL injection, command injection occurs when input is directly passed to a system shell. For example, a web form that passes unsanitized input like to system bracket or exa bracket functions could allow attackers arbitrary to run arbitrary commands. This could result in full server compromise, data exfiltration, or lateral movement. Defense includes proper input validation, avoiding shell execution of input, and secure APIs. Cross-site scripting, or XSS. XSS is all about tricking the browser. Attacking inject Attackers inject malicious JavaScript into websites. Have you ever seen a site show an alert box unexpectedly? You might have witnessed an XSS test. It can steal cookies, hijack sessions, or deface content, like this one on the screen. Broken authentication. Broken authentication refers to flaws that allow attackers to compromise passwords, keys, or session tokens, or to exploit other implementation flaws. To assume others use identities, if authentication and session management are improperly implemented, attackers could gain unauthorized access to systems. Defense includes strong password policies. MF secures secure session management and avoid predictable login URLs. Privilege escalation. This vulnerability allows attackers to gain high access rights, then gain this vulnerability allows attackers to gain higher access rights than they're supposed to. It often happens when programs run with excessive permissions or due to flaws in OS level permission handling. Local privilege escalation is common in post exploitation phases. Zero-day vulnerabilities. These are the most dangerous. A zero-day vulnerability that has been patched or even publicly disclosed hasn't been patched or even publicly disclosed. Once discovered by attackers, it can be weaponized before developers even know it exists. That is why it's called zero day. 0 days to respond. Denial of service, or DOS, DDoS. Not all attacks steal, some just destroy. Denial of service and distributed denial of service attacks flood a system with traffic or requests, overwhelming resources and making services unavailable. Science here involves network bandwidth, throughput, and process handling. Insecure Direct Object References, or IDOR. IDOR happens when applications expose internet internal object references like URLs or database keys without proper access controls. If I can change a URL like profile I did equals 123 to profile question mark ID equals 124, and someone else's sees someone else's data, that's an IDOR flaw. Common root causes. Most vulnerabilities stem from two key areas: poor coding and human error. And outdated software and misconfigurations. Poor input validations, hard coded credentials, or skipping security reviews lead to weak software. Meanwhile, outdated libraries and insecure default settings create exploitable gaps. Consequences of exploits. The impact of an exploit can be massive. Beyond technical damage, the consequences include data breaches, regulatory fines, financial loss, intellectual property theft, and reputational damage. Real world examples like the Equifax breach or Log4Shell exploits shows how one vulnerability can have global repercussions. Secure coding practices. Starting with the basics, validate every input. Escape outputs. Use secure libraries. Follow standards like OSWAP WASP's Top 10. Train developers Think about security from day one, not after deployment. Testing and hard coding and hardening code. Software security should be baked in, not sprinkled on. Use statistic and dynamic analysis tools to test for vulnerabilities. Apply input fuzzing to uncover edge case issues. Code hardening includes minimizing attack surfaces, using compiler protections like stack canaries, and enabling ASLR. Patch management. Always patch. Automate where possible. Use tools to track dependencies and versions. Vulnerabilities do not wait for your update schedule. A delay in patching is a window for attackers. Incident response and monitoring. Preparation is key. When vulnerability is exploited, how fast and effectively you respond determines the damage. An incident response plan outlines roles, communication channels, and procedures for detection, containment, and recovery. Regular drills ensure your team is ready. And looking at the life cycle, preparation, detection, analysis, containment, eradication, recovery, and lesson learned. The future of vulnerability management. Looking ahead, we'll see more automation through AI, for threat detection and response, broader adoption of DepSecOps for integrated security throughout development, and better vulnerability disclosure and collaboration via programs like bug bounties. All systems grow more complex, continuous monitoring, threat intelligence sharing, and predictive analytics will become essential in staying ahead of attackers. And here is the references that I used to write this page and project. I hope you had a good time listening to this. And if you have any more questions or interest in learning more things, refer to the references and have a good day.